Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in mathematics we had started the chapter real numbers. Now let us go for continuing that, and this is the fourth period of the chapter real numbers. In this chapter, first we had discussed about the properties of positive integers. One is Euclide's division algorithm, which can be used to find out the HCF of given two positive integers. Second one is the fundamental theorem of arithmetic. This can be used to find out HCF as well as LCM. Then we solved some problems to find out the HCF of given two positive integers using Euclid's division lemma. And also we focused on some of the verbal problems. You may just recall the very first one is it was about tanker's problem. Second one was egg seller. Third one sweet seller, right? And in addition with that, one more type of problem, that is even number and odd numbers can be expressed in some particular form. Even number can be written as 2q, 4q, 6q, 8q and so on. Whereas odd number 2q plus 1, 4q plus 1, 4q plus 3, 6q plus 1, 6q plus 3, 6q plus 5. Similarly, we have also come across one more important point, that when a number is divided by 3, the possible remainders are 0, 1 and 2. Then if a number is divided by 5, the possible remainders are 0, 1, 2, 3 and 4. Right? Okay, this much we had discussed. Now, let us go for continuing this chapter. In the next part of the chapter, we are going to solve the problems in exercise 1.1. So, you have to write with me the very first one. It is, first you write side heading, exercise 1.1. In that first one, use Euclid's division algorithm to find out HCF of. Use Euclid's division algorithm to find out the HCF of. The very first one, it is 135 and 225. It was already over. The HCF was 45, right? So we can write solve. Second one, it is 196 and 38,220. Don't go for copy, just listen to me carefully. Here, to find out the HCF of these two numbers, first we go for writing the bigger number first, 38,220, which is greater than 196. Now you can go for applying Euclid's division algorithm. So according to Euclid's division algorithm, it should be expressed in the form of A equal to BQ plus R, right? So I go for dividing 38,220 by 196. Now see that as it is 3, divisor is 3 digits. So here I will go for taking 3 digit number, 382. So 382 is there. 196 how much are? If you go for taking 2s are, it will be close to 400. So will not come. Hence I go for 1s are. 196 1s are 196. Subtract 12 minus 6. It is 6. Then here 7 will remain. 17 minus 9. 8. 2 will remain. 2 minus 1. 1. Now carry down to 1862. Now see that here 4 digit number, almost close to 1900, but this is 196. If you want to get 4 digit, then it is tensa, 1906 tensa, it will be, 196 tensa, 1960. That will be more number and bigger number, hence I go for taking 9s. So now 9 6 are 54, 5 is the carry. Then 9 9s are 81 plus 5, 86, 8 is the carry, 9 1s are 9, 9 plus 8. It is 17. 1764. Now subtract. 12 minus 4. It is 8. 5 will remain. 15 minus 6. It is 9. 7 will remain. 7 minus 7, 0. 1 minus 1, 0. Now carry down 0. Now 196. How much the? It is 980 is there. You just go for doubling, tripling, 4 times, 5 times. 196 5s are. How much it will be? 980. Now it is 0. Now we can write 38,220 as 196 into 195 plus 0. In the very first step only, we got the remainder as 0. Hence, the divisor will be HCF. Therefore, we can write HCF of 196 and 38,220 as 196. I hope that you have understood. Now, I go for one more. It is third one. 867 and 255. The same method has to be followed to find out the HCF. Here on right, first the bigger number is 867, which is greater than 255. You can go for applying Euclide's division algorithm in the form of, should be expressed in the form of A equal to BQ plus R. Therefore, let us go for dividing 867 by 255. 255, how much are? See the double, if you go for doubling, it is 500, almost close to 500. Next, tripling, 750. 4 times, it will cross 1000. Hence, 3s are. 255, 3s are, it is 765. Now, 7 minus 5, 2. 6 minus 6, 0. 8 minus 7, 1. We can write 867 as 255 into 3 plus 102. Now see the divisor 255 is greater. Hence, we can go for continuing this. Now divide 255 by 102. Now 102, how much are? If you take twice, it will 200 plus. If you go for thrice, it will be 300 plus. Hence, you can go for taking 2s are. 102 2s are, it is 204. Subtract 1, 5. Here, 0. Now, we can write 102 can be, 255 can be written as 102. 2s are plus 51. Now, the divisor, remainder is not equal to 0. You can go for continuing this. 102. Divide 102 by 51. 51, how much are? 2s are, it is 102. Remainder is 0. Now we can write 102 as 51. 2s are plus 0. Now remainder is 0. Then the divisor will be HCF. Therefore, HCF of 867 and 255 is 51. This is the second problem. So now you have to pause the video, should copy both the problems. Now we will move on to the next problem, that is second one. I'll go for writing it. Yes, you have copied that. Now focus on the second problem. Don't copy this one, just listen. The question is, show that any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3, or it may be 6 cube plus 5, where q is some integer. Now, let us go for proving this. Show that any positive odd integer. What is that positive integer? It is unknown to us. Let us go for assuming. I'll write it as let a be any positive integer. Then you can go for applying Euclide's division algorithm According to Euclid's division algorithm, we can write A equal to BQ plus R, where 0 is less than or equal to R less than B. Call it as statement 1. Now see that odd positive integer, it should be in the form 6q plus 1, 6q plus 3 or 6q plus 5. Here BQ plus R is there. So could you tell what substitution to be taken in place of B? Yes, you are right. It is B equal to 6. Alright. Substitute B equal to 6 in the statement 1. Then I can write this as A equal to 6q plus 6q plus R. And we know that 6 is the divisor. If 6 is the divisor, what are the possible remainders? Then the possible remainders are, it is 0, 1, 2, 3, 4 and 5. Now let us go for taking these numbers in place of R, one by one. If 0 is taken in place of R, then A equal to 6q plus 0. Any number plus 0 is the number itself. Hence I'll write just 6q. Now can we write 6q in the form of 2 into 3q? Yes, 2 3s are 6. Call this statement as 2. If R equal to 1, then A equal to 6q plus 1. In place of R, we have written 1. Then it cannot be simplified further. I have kept it as it is. This is statement 3. If R equal to 2, then A equal to 6q plus 2. This can be rewritten as, here 2 is the common factor. Then you can write 2 how much are 6? It is 3. Q as it is. 2 how much are 2? 1 are. Now call this as statement 4. Next, if R equal to 3, then A equal to 6q plus 3. Call this statement as 5. If R equal to 4, then A equal to 6q plus 4. Again, you can take a common factor. What is that? It is 2. Then inside the bracket we can write 3q plus 2. Call it as 6. Next, if R equal to 5, if R is 5, A equal to 6q plus 5. Then call this as statement 7. We are very familiar with even numbers and odd numbers. Even is a number which is divisible by 2. Odd is a number which is not divisible by 2. Let us go for identify the number which are divisible by 2. Because if even number are identified, it is very easy to take the remaining as odd. Here, come across the second statement. See the 2 into 3q. Is it divisible by 2? Yes. Therefore, statement 2 is even. Nothing but 6q is even. Whereas, here it is also divisible by 2. Then, statement 6 is also divisible by 2. Here are write statements 2, 4 and 6 are divisible by 2. Therefore, they are even. They are even. But we want odd numbers. The remaining, that is, see that 6q is even. When 1 is added to it, it will be odd. So now, statement 3, then statement 5 and statement 6 are not divisible by 2. Therefore, what do you call them? Therefore, They are odd. What are those? They are. One is 6 cube. Therefore, 6 cube plus 1, then 6 cube plus 3 and 6 cube plus 5 are odds. Hence, we can conclude that is any positive odd integer is of the form, any one of these forms. Alright. Hence, any positive odd integer is of the form either 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5. I hope that you all have understood this. Then you have to go through this again, and even the same question can be asked in another way as show that any positive odd integer is of the form 6m plus 1, 6m plus 3, 6m plus 5. Under such condition, you can go for taking the substitution as b equal to 6 as it is. Here in place of q they have given m. You can write q equal to m. Clear? It is one of the important type of problem which was asked in the examination many times. You have to practice it. Now, please pause the video and complete it. Observe it. It is the third problem in exercise 1.1. Look at it. Don't copy. First, go through the statement once. An army contingent of 616 members is to march behind an army band of 32 members in a parallel. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? This is the question. Very simple. Here they have given two groups. One is army contingent and second one is band group. They have to, here the army contingent should move behind army band group. Then what should be the maximum number of columns in which they can march? Here you can go for taking just two columns. See that if you go for arranging them in two columns, all 616, in one column 308 will be there, another column 308 will be there. Here 32 are there. In one column 16 and 16, it will be exact, right? Even you can go for making 4 columns because both the numbers are divisible by 4. But you are going to find out what is the maximum number of columns in which they can march, such that nobody should be there out of the parade. Our arrangement should be in such a way. Hence, can we say that it belongs to HCF of the two positive integers? Yes, you are right. Now let us go for solving. Observe, don't copy. First, let us write the given information. Here, 660 members. What are they? They are army contingent. So here, I'll write number of army contingents. It is equal to 616. Then how many band group members are there? Here 32. So number of army band members is equal to 32. You are going to find out maximum number of columns in which they can march. So we can write maximum number of columns in which they can march. So which concept has to be used? Yes, it is right, HCF. Here I'll go for calculation. This is data. In calculation, maximum number of columns is equal to HCF of 616 and 30. Let us go for finding HCF by using Euclid's division algorithm. Here 616 is greater than 32. Now by Euclid's division algorithm, let us express these two numbers in the form A equal to BQ plus R. Hence, I go for dividing 616 by 32. Now see that two digits are there. I can go for taking two-digit number here, 61, which is greater than 32. 32 how much are? If you go for taking ones are 32, twos are 64, but this number is less. Hence, I'll go for ones are. 32 ones are 32. Now 11 minus 2, 9. Here 5 is there. 5 minus 3, 2. Now carry down 6. 296. Clear? Okay, 32. How much are 296? It can be guessed easily. 32 tens how much? It will be 320. Right? And this is close to 300. Hence we can go for 9s are. Let me write. 9 2s are 18. Carry 1. 9 3s are 27 plus 1. 28. Now 16 minus 8. It is 8. 8 minus 8, 0. 2 minus 2, 0. Now we can write 616 is equal to 32 19s are plus remainder 8. Now remainder is not equal to 0. Hence you can go for continuing the same procedure. 32 is greater than 8. Divide 32 by 8. 8 how much are? 8 4s are 32. It is 0. Now here I will write 32 is equal to 8 into 4 plus 0. Remainder is 0. Hence the divisor will be HCF. I can write therefore HCF of 616 and 32 is 8. Hence we can write the conclusion that therefore the maximum number of columns in which they can march is 8. Here I will write hence the maximum number of columns in which the army members can march is 8. I hope that you have understood this. Even could you tell another simple question in this one only, not given, just I am including to test your knowledge. In how many columns they can go for marching? Yes, it is 8. If it is so, in one column, how many members will be there of army contingent? Very simple. When you divide 616 by 8, you will get a number, those will. Then how many members will be there? How many army band members will be there in one column? 32 is there. 32 by 8, 4. 4 will be there. Got it? Even they may ask all together how many total members will be there in one column. Then you should go for adding both of them. Clear? So when the problem is given, you have to, after learning this, you have to think in other way, how they can ask. You only try to guess. And if not known, then you have to discuss with your school subject teacher. Okay, now you are going to copy this. Please pause the video, copy up to here. Go for it. Dear students, I hope that you have copied, and after copying, I just ask you to think about the number of members in that one particular column. Just here I have written. See that HCF was 8. Number of contingents in one column. 6 and total 616 divided by 8. You will get 77. And number of members in that band group. It is total 32 by 8. It is 4. So in one column 77 Contingents are there, 4 band group members are there. All together in one column 81 members are there. It is just for the sake of information only. Okay, now we are moving to another very important problem. Here I have written, please go through this. Here also don't copy, observe this. Use Euclid's division lemma to show that the square of any positive integer is of the form 3m or 3m plus 1 for some integer m. Just we have come to know a positive integer, if it is even in one particular form, odd integer that is also in one particular form. But here they have given square of any positive integer. This must be kept in your mind when you are proving this. Okay, let us go for that. Observe this carefully. Proof. We do not know what is that positive integer, hence let us assume this as a. Let a be any positive integer. Positive integer. Then when you apply Euclid's division lemma or algorithm, how do you go for writing? Yes, you are right. It is a equal to bq plus r. Then what is the condition? Do remember the condition. 0 is less than or equal to r less than b. You may call it as statement 1. Now, the square of any positive integer is of the form 3m or 3m plus 1. So, bq plus r in place of b, what should be substituted? 3 should be substituted. Here I will write. So, substitute b equal to 3 in the statement 1. Now we can rewrite this as a equal to 3q plus r. What is the divisor here? Yes, 3. Then what are the possible remainders? The possible remainders are 0, 1 and 2. Now let us go for taking one by one. If r equal to 0, remainder is 0, then a equal to 3q plus remainder is 0. So just write 3q. What has been given? You don't call it as statement 2 because in the statement it has been given that square of any positive integer. Hence, this is the positive integer. We have to take its square. What should be written here? Very good. It is squaring on both the sides. Squaring on both the sides. It is a whole square, 3q whole square. Now, a whole square is a square. 3q whole square. Please do remember, square should be applied to both 3 and q. What is 3 square? 9. Q square as it is. So, a square equal to 9q square. Now, we can write it as 3 into 3q square. Is it not? 3 3s are 9. You may be thinking that, sir, why it is so? Because we know that you are going to express the square of any positive integer either in this form 3m or 3m plus 1. Here I write it can be written as 3m. Then what is m? So m is 3 square. Sorry, 3q square. M equal to 3q square. I hope that you have understood this one. A square equal to 3m, where m equal to 3q square. I call it as statement 2. Next, let us see if r equal to 1. Here, r equal to 1. If r equal to 1, then what can be written? A equal to 3q plus 1. Then squaring on both the sides, because square of any positive integer, on squaring you get a whole square, 3q plus 1 whole square. Now it is of the form an identity. What is that identity? You are right, it is a plus b whole square. What is a plus b whole square? It is a square plus 2ab plus b square. I am going to write in the same form. A a square plus 2ab plus b square. Now, here this a square as it is. What is in place of a? It is 3q. b, 1. So, 3q, 1. It is 1. I hope that you have understood. Now, simplify this. What is 3q whole square? Apply square to both. 3 square is 9. Q whole square is q square. Plus, multiply constant. 2 3s are 6. 6 into 1, 6. 6q plus 1 square is 1. Clear? Now, I am going to take only first two terms. Why? As that given the statement, it should be either in the form 3m or 3m plus 1. Here, in first two terms, 9 and 6 are the multiples of 3. Hence, I can go for taking 3 as common factor. 3 into 3, how much are 9? 3 3s are. Then q square as it is plus. Then 3, how much are 6? 2s are 2q. 1 is separate. So, it will not affect the statement. Now, this can be written as 3m plus 1. What has been taken in place of m? So, m indicates 3q square plus 2q. I hope that you have understood. Now, I call this as statement 3. Now, one more possibility is there. If r equal to 2, let us go for that. If r equal to 2, then statement will be a equal to 3q plus 2. A equal to 3q plus 2. Again apply squaring on both the sides. It will be a whole square. This will be a square plus 2ab plus b square. Then a is 3q. Then here I'll write squaring on both the sides. B is 2. Here I'll write a is 3q, b is 2. It is equal to, now a whole square is a square. 3q whole square, again I should tell the same thing. Apply square to both of them. 3 square is 9, q whole square is q square. 2 3s are 6, 6 2s are 12. Q 2 square is 4. Now, in all these, whether all these 3 are the multiples of 3? No, only first two terms. But when you take only first two terms, it will be plus 4. But we want plus, we have to show that 3m plus 1. Hence, I go for splitting 4 as 3 plus 1. Here I will write 9q square plus 12q. 4 is written as 3 plus 1. Now, in the first three terms, what is common factor? 3. Because all are the multiples of 3. Then 3 3s are. Then q square. 3 how much are? 4s are. 4q as it is. 3 how much are 3? 1s are. Plus 1 will remain as it is. This is equal to 3m plus 1. That means we have taken m in place of 3q square plus 4q plus 1. Hence I will write m equal to 3q square plus 4q plus 1. Call it as statement 4. Observe statement 2, statement 3 and statement 4. So from all the three, we can come to know that here the square of any positive integer either in the form 3m or 3m plus 1. Understood? Here I'll write from the statements 2, 3 and 4. We can conclude that the square of any positive integer is of the form. What is that? It is 3m or 3m plus 1. Hopefully you all have understood this. Usually in the examination, we won't expect this step. Only for the sake of understanding, I have written. You can write it directly. See, a square, 3q whole square directly. 9q square, 2ab, 2 into 3 into 1, 6 into q. Then b square, 1 square is 1. Okay, this is very important. Can be given in the examination for 3 marks. 3 marks. Let me tell you the marks allotment. See that here only first you will assume a is any positive integer, and using Euclid's division lemma you will write the statement a equal to bq plus r, where 0 is less than or equal to r less than b. It is half. Then you will go for taking substitution. You will write the possible remainders, that is half. Next, these terms here, it is for this statement half, and you will apply for this statement half, and for this half. Conclusion half. So altogether it will be 3 marks. Please do practice. Now you have to pause the video, write with patience. Copy this completely up to here. I'll move on to the next one. Yes, go through. Fifth one. It is also of same type, but cube is given. Go through the given statement. It is use Euclid's division lemma to show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. Then obviously same thing, we do not know what is that positive integer. Let us take a. Let a be any positive integer. Using Euclid's division algorithm or lemma, we can write a equal to bq plus r, where 0 is less than or equal to r less than b. Call it as statement 1. It is common. Then we have to take substitution. Here 9m plus 1, 9m plus 8 is there. What will go for taking the substitution? For b, do you say that it is 9? Of course you can go for taking 9. Then what will be the possible remainders? R equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. We find it consumes our time to solve that completely by taking the remainders from 0 to 8. Hence, we can go for taking 3. Then you all may be thinking that why sir is telling to take 3 in place of b. I give you the reason. What is here? You are going to express that in cube of any positive integer in this form. If you go for taking 3, what is cube of 3? Yes, 3 cube. How much? 27. 27. Is there any relationship between 27 and 9? Yes, you are right. We know that 27 is the multiple of 9. Hence, you can go for taking 3 in place of 9. That is in place of b. Here I write substitute b equal to 3 in 1. That is, in this problem particularly I am using the blue color. Only the changes what we have made. Now further, if 3 is taken in place of b, a equal to 3q plus r again, and what are the possible remainders? 0, 1, 2, right? Now let us go for taking 0 in place of r. If r equal to 0, then a equal to 3q plus 0. Can we write just 3q? Yes, a equal to 3q. But what has been given? Cube of any positive integer. Hence, I go for taking cubing on both the sides. Then cubing on both the sides, a whole cube is equal to 3q whole cube. Is it not? What is a whole cube? It is just a cube. 3 whole cube. 3 whole cube. Apply cube to both. 3 cube. What is 3 cube? 3 into 3 into 3. 3 times. 3 3s are 9. 9 3s are 27. Alright. 27. Now, apply q to q also. It will be q raised to the power 3. A cube equal to 27 q cube. But cube of any positive integer is of this form. As I said earlier, 27 is the multiple of 9. Hence, I can write it as 9 into how? 9 how much are 27? 3 is 3 cube. Now, it can be written as 9m. So, what is m? M equal to 3 q raised to the power 3. I call it as statement 2. So again, to highlight this, I will go for using the blue mark. Next. Similarly, we have to take 1 and 2 in place of r. If r equal to 1, then a equal to 3q plus 1. Now, cubing on both the sides. Then a whole cube, it is 3q plus 1 whole cube. Now, in which form it is? It is in the form of an identity, right? What is that identity? Identity is, it is a plus b whole cube. What is a plus b whole cube? Here I write. A plus b whole cube, it is equal to a cube plus b cube plus 3a square b plus 3ab square. You can also write it as a cube plus b cube plus 3ab into a plus b. But this will be easier. Now, I go for simplifying this. A cube plus b cube plus 3a square b plus 3ab square. What is A? A is 3 cube. B 1. Here A 3 cube 1. 3 cube 1. Got it? Now it is equal to, apply cube to both. 3 cube is 27. Q raised to the power 3. Plus 1 cube is 1. Then apply here, very important, 3 ones are already 3. Now apply square to both. 3 square is 9. 9 threes are 27. 27 ones are 27. Q raised to the power 2. Plus here 1 square is 1. 1 threes are 3. 3 threes are 9. So 9 cube. It can be rewritten as 27 q raised to the power 3 plus 27 q square plus 9 q plus 1. Just I have written in standard form. Now observe, in the first 3 terms, all are the multiples of 3. Hence we can go for taking, all are multiples of 3 as well as 9. But you are going to express the cube of any positive integer in the form of 9m, 9m plus 1 or 9m plus 8. Hence I go for taking 9 as the common factor. 9 how much are 27? It is 3 q raised to the power 3 plus 9 how much are 27? Again 3 q square. 9 how much are 9? 1 so 1 q. Separately we can write plus 1. Next, this is equal to 9m plus 1. Means in this place I have written m, where m is equal to, what is that? 3q plus 3q square plus q. You may call it as statement 3. So now I am going to highlight that. It is aq. Next, one more is there. What is that? If r equal to 2, let us say that. If r equal to 2, then a equal to b cube plus 2. Here I will write. A equal to b cube plus 2. Now cubing on both the sides. A whole cube, then b cube plus 2 whole cube. Sorry, what is b? It is 3. 3 cube plus r, 3 cube plus 2. Now, on applying cube on both the sides, we will get a cube plus b cube plus 3a square b plus 3ab square. Now, what is a? It is 3q. b, 2. a, 3q. b, 2. Then a square b. A is 3q. b is 2. It is equal to, what is a cube? A whole cube is just a cube. Now 3q whole cube. Apply cube to both. 3 cube is 27. I have already shown that. Q whole to the power 3 is q raised to the power 3. Plus, what is 2 cube? 2 cube is, here I'll write, 2 cube equal to 2 into 2 into 2. 2 should be multiplied 3 times. 2 2s are 4. 4 2s are 8. Plus, now it's very important. First, you go for applying square. What? Square to both. What is 3 square? Very good. 9. 9 3s are 27. 27 2s are 54. Then q square. Plus, here also first apply. It is 3a square b, 3ab square. Now, apply square to 2. 2 square is 4. 4 3s are 12. 12 3s are 36. Q only. Now, let us write it in standard form. 27 q raised to the power 3 plus 54 q raised to the power 2 plus 36 q plus 8. Now this is equal to, observe the 3 terms. All these 3 terms are the multiples of 9. I go for taking 9 as the common factor. 9, how much are? It is 3 is 9. 3 is 27. Cube as it is. 9, how much are? 54. It is 6 are. Q square as it is. 9, how much are? 36. 4 are 4q plus 8 as it is. Now this is equal to 9. So can I write m in place of these 3 terms? Yes, because it should be expressed in that form. Plus what is remaining? It is 8. Now we can write where m equal to 3q raised to the power 3, 6q square plus 4q. Now I call this as statement 4. Again I am going to highlight that with a blue color marker. Now observe the statements what I have written in the box here. Statement 2 in which form? Yes, 9m. Statement 3 in which form? 9m plus 1. Statement 4, it is in the form 9m plus 8. Then can we write the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Yes, let us go for writing the conclusion from statements 2, 3 and 4. We can say that, we can conclude or say that, we can say that the cube of any positive integer is of the form. In which form it is? It is either 9m or 9m plus 1 or 9m plus 8. Got it? So it is also one of the important problem what I said earlier. So I have put star mark. Practice them as many times as possible. Till you understand that, please don't stop practicing. Clear? Now you have to pause the video and should copy it from here to there. Yes, copy that. Yes, dear students, just we have finished exercise 1.1. With respect to this, let us go for taking few additional problems from reference books. So as I said in the beginning, we are going to use the reference books. One is S. Chan, second one is R.D. Sharma. In forthcoming days, other books will also be used. See, this is S. Chan. From this, I am going to take one problem that has been already written on the board. Look at it. So far we have learned how to find out HCF of two given positive integers using Euclid's division lemma. Now the question will be asked like this: find the HCF of three numbers, that is 120, 224 and 250 using Euclid's division lemma or algorithm. How to find out them? Let me show you that. Let your concentration be here. Three numbers are there. So let us go for arranging them in a particular order. I take this as increasing order. Which is the smallest one? 120. Next one? 224. Next one? 256. They only have given the order. To find out the HCF of these three numbers, first you should find out HCF of first two numbers. What are those? 120 and 224. In 120 and 224, 224 is greater than 120. So apply Euclid's division algorithm. Then 224 can be written as 120. How much are? Again, we will go for directly it can be written. Anyway, ones are right. 224, it should be divided by 120. 122s are, it will be 240. Hence I go for taking ones are. 121s are 120 and 4. The remainder 4 here 0 here 1 104. Here 121s are plus the remainder 104. Next, remainder is not equal to 0. Continue this. 120 can be written as 120 is greater than 104. Divide 120 by 104. 104. Ones are, I am writing it directly. How much will remain? 120 minus 104. It will be 16. Then 104 is there. Then 16. How much are? See that 104 is greater than 16. Hence, we can continue this. 16 5s are 80. Then 16 6s are 96. How much will remain? Yes, you are right. 8 will remain. If you know, you can write it directly. If not, please use the working column. Again, remainder is not equal to 0. Continue, please. So 16 is equal to 8. How much is 16? 2s are plus 0. Remainder is 0. What is the divisor? 8. Therefore, HCF of these two numbers, what are? 224 and 120 is 8. After getting this HCF of first two numbers, then you go for finding the HCF of the last number 256 and the HCF what you have got, that is 8. Here I will write it. Now 256 is greater than 8. I am going to encircle it to highlight. This 8 has been taken. Now 256, apply Euclid's division lemma. 256 is equal to 8. How much are? You can go further. Very simple one. 256 on dividing by 8. 8. 3s are 24. How much will remain? 1. Carry down 6. 8 how much is 16? 2s are 16. 0. So 8 32s are plus remainder 0. As the remainder is 0, divisor will be HCF. So HCF of, therefore HCF of 256 and 8 is 8. Got it? And conclusion. Hence, the HCF of all these three numbers, 120, 224 and 256 is, that is what the final number, that is 8. Hence, the HCF of 120, 224 and 256 is 8. Clear? Please do practice. Even few more problems are given in your S chart as well as RD Sharma. You can work out by taking more number of problems. Now, please pause the video and copy from here to there. Yes. Dear students, here I have brought one more important problem. Just go through this. It has also been taken from the reference, but I have made little bit changes. Go through this. Additional example, second one. If the HCF of 210 and 55 is expressed, it can be written in the form of 210m plus 55n. Then we have to find out the values of m and n. One thing. After finding the values of m and n, we should also find out the value of m square plus n square. It can be changed. Just they may ask, find 2mn, m cube minus n cube, m square minus n square, like that. Just here I have taken only one, m square plus n square. Let us concentrate on the solution. If the HCF of 210 and 55, do you know the HCF of 210 and 55? Don't know. Let us go for finding that. Here I will write 210 is greater than 55. Then by using Euclid's division lemma, then 210 is equal to 55. How much are? You can take 55 threes directly, but anyhow, again I will write it and I go for using this column. 210 should be divided by 55. 55 threes are, it is 165. Then 10 minus 5, 5 0 will remain. 10 minus 6, 4, 45. Here I will write 55 threes are plus remainder 45. Now remainder is not equal to 0, continue. 55 is equal to 45, how much are? 45 ones are, what will remain? 10. Then 45 is there. Here 10, remainder is not equal to 0, continues. 45, then 10 how much are? 10 fours are, remainder is 5. 5 is the remainder which is not equal to 0, again continue. 10 is equal to 5 how much are? 5 twos are, plus remainder is 0. Then what about the divisor? 5. Then HCF of, therefore HCF of 210 and 55 is 5. I hope that you have understood this. Now the question is very important, the sub question. It should be expressed in the form of 210m plus 55n. But how to express this? Here I will write. What should be? It is HCF. HCF is 5. This HCF should be written in this form. 210m plus 55n. Then how to write 5 as those numbers? Again, you have to take these steps, well-defined steps, what we have used to find out HCF. Here 5 is there first. See, 5. In these steps, 5 is here. Go for solving 5 from this statement. 5. Then 45. Take 10 into 4 to the left hand side. It will be minus 10 into 4. Clear? Just for the sake of understanding, here I am writing 45 is equal to 10 into 4 plus 5. Then we want 5. Keep that 5 as it is. In the left hand side, 45 as it is. Transfer 10 into 4 to the left hand side. Minus 10 into 4. Clear? This is the way we have to solve. Here I will write 5 can be written as 45 minus 10 into 4. Means 10 is 4 times. Then, now 5 is written in this form. But what it should be? It should be in the form of 210m plus 55n. Now 45 is there. Here 45. Take substitution for 45. Solve from this. 45 can be written as 210. Transfer this. 55 into 3. It becomes minus 55 into 3. Here I will write 210 minus 55 into 3. minus, next 10 into 4, that is 10 is 4 times. 4 times, I will write this as it is outside. Now let us take substitution for 10. What is 10? 10 is here. 10 equal to 55 minus 45 ones up. 55 minus 45 ones up. Clear? Please do concentrate. It's equal to 210 minus, don't go for multiplying this, 55 3 times as it is, multiply by minus, minus 55, here 4 is there, 4 times, minus into minus, plus 45, then multiply 4, 4 into 1, 1, sorry 4 into 1, 4, 4 times. Now this is equal to, see 210, here 1 time, that should be written as it is, 210 minus 55, minus 55 3 times, minus 55 4 times, total minus 55 7 times, plus 45 is there. So we have to take substitution for 45 into 4 times as it is. 45, here it is, because we have to express 5 in this form, only 210 and 55 should be there. 45 can be written as 210 minus 55 3s are. 210 minus 55 3s are. Clear up? It is equal to 210 minus 55 7 times. Now multiply 4. 210, how many times? 4 times. Minus 55. Multiply 4. 4 3s are 12. 12 times. It's equal to 210. Here how many times? 1 time. Here how many times? 4 times. Altogether 5 times. Understood? Now this minus 55. Minus 55 how many times? Here 7 times. Here 12 times. Altogether how much? It is 19 times. 12 plus 7. 19 times. It is equal to, now 210 5 times, then plus 55, take minus inside, minus 19 times. Now see that this is of the form 210m plus 55n. I'll write it. Yes, it is 210 m plus 55n. Can we write so? Yes. Now if you can write is of the form in this. HCF is 5. I just go for highlighting that with a box. Now could you tell what is in place of m? In place of m, 5 is there. And in place of n, minus 19 is there. Now let me go for highlighting this also. We have found out the values of m and n. Next what we have to find out? M square plus n square. M square plus n square, it is equal to, where m is 5 whole square plus n is minus 19 whole square. It is equal to 5 square is 25. 19 19s are, it is 361. So I'll write 361. It is equal to, what is 361 plus 25? 5 plus 1, 6, then 2 plus 6, 8, and 2 plus 3, sorry, only 3 as it is, 386. Got it? It is very important one. This type, even some small numbers or bigger numbers can be given. You have to practice this. First you will find out the HCF, then you will go for expressing the HCF of the given numbers in the given form. Clear? Okay, now you have to pause the video, then copy from here to there. Okay, dear students, before concluding the class, again I am reminding you, whatever we have covered today, please practice them today itself. Then you find it easier to follow the chapter. Got it? Practice as many times as possible. So with this, let us stop the class. Thank you.